Hey everyone, my name is Christy and I'll be walking you through the spring 2022 final, problem number 10, two tree. So a two tree is a tree where every node has the conditions 1, so they can either have a value of 0 or 1, or you could have at most 2 children. So an example of a valid two tree is tree 0, and then inside is an array of tree 1, tree 1. So what this looks like is our root node is 0, and it's going to have two branches, each with the node 1. So some examples of invalid two trees include tree 2. So I'm going to label these are bad. So tree 2 means it's just like one node of 2. And the reason why this is bad is because we can only have values of either 0 or 1. So that violates that rule. And our second example that's bad is, so I'm going to draw the tree. So it's 0, 0, 0, 1. Okay, this is bad, even though, okay, so first off, we notice that all the values are either 0 or 1, so that meets the first condition. However, this one has 3 children, and our rule is that we can only have at most 2 children, which is why this is an invalid two tree. So we're given the possibly buggy add nums function, which should return the sum of all the values in the input tree. So basically, the point of this function is to count up all like the values for each node. And for parts A through D, we want to write any valid two tree T that makes the statement true. And if none exists, write impossible. So for part 1 of this question, it says add nums T is supposed to return 2 and does return 2. So a valid two tree that looks like that could be, okay, this and this, right? Because we have our root node is 1, and then its branch is 1, and 1 plus 1 is 2, and that should return true. So copying like the same format as the examples they gave us here, this would correspond to tree 1, and there. That should return that tree. Okay, moving up to part B. Add nums T is supposed to return 3, and it does return 3. So let's think of like a tree that would pass this test. So we could have like the root be 1. Okay, they could have 2 children. And this should, when calling add nums on this should return 3 because 1 plus 1 plus 1 is 3. So copying the same format, 1, and then tree 1, tree 1. There. Okay, moving on to part C. Add nums T is supposed to return 3 and doesn't return 3. So we want to think of a scenario where it doesn't return 3. So this is what I think of like this could be a valid two tree that doesn't pass this case. So like for this question, there are multiple examples. For instance, we could have like we could have this two tree. This would also be like a valid answer because it's supposed to return 3 but doesn't return 3. But the reason this doesn't return 3 is that, okay, if we look at our add nums function as a count, and it searches through t dot branches, and t dot branches corresponds to like the branches of t. So if this is t, the branches, these are its branches. But let's say t also had like 2 more branches under like this one node. So like 1, 1. This for loop wouldn't search through these branches. It would only search through the ones right here. Therefore, this is why this is the possibly buggy part of like this function. So if we had like these two scenarios, it would look at here and it would look at here, but it wouldn't look at here. Therefore, this would only return a value of 2, but we want 3, right? Same with this example below here. So let's write that to code. Tree 1, and then tree 0, and a bracket tree 1, tree 1. Let me check if my things match. Okay. Yep, Okay, the brackets and the parentheses notation are a little bit tricky, so be sure to keep an eye out for that one. Okay, let's see. Part D. Adnums T is supposed to return 4, and it does return 4. Okay, so we already know by our first two rules, the value can either be 0 or 1, and it can be at most 2 children. And based on part C, we realized that we only search through like the first level and the second level, but we don't search up anything after that. So at most, our tree, like since we can only have values 1 or 0, like the maximum it can ever be is 3. Because if we want a value of 4, like that means we would have to have like extra branches stemming from like the nodes here, but we know that adnums never searches anything past this level, right? So this would be impossible. And we don't need to write an example, like a reason why, because it just says to write impossible. Hopefully that helped. Good luck with studying.